These are the notes for AP Calculus on the topic of solving differential equations for exponential and logarithmic functions are involved. So it says find the particular solution y equals f of x, so it's a function, to the given differential equation. So we're starting with the derivative with this initial condition f of 2 is 0, which means you have the point 2 is 0 as a point on the original function. So we're basically trying to go from the derivative here back to the original equation. And the first thing we can do is separate the variables. So since the derivative is a fraction, you could cross multiply. But notice what that would give you is x cubed dy equals 2y minus 1 dx. It gets rid of the fractions, however, notice the x is on the wrong side. It should be with the x dx. And so is this y, it's into the 2y minus 1. So to separate them, we have to then divide by x cubed and also divide by 2y minus 1. So now let's look at what we're left with here. The x cubes reduce out, so on this side we have 1 over 2y minus 1 dy, and on this side 2y minus 1 is reduced out, where we have 1 over x cubed, which could be written as x to the negative 3 dx. Now the variables are actually separated. And once they're separated, then what that allows you to do, remember, is we want to get back from the derivative back to the original equation. So that requires finding the antiderivative, integrating both sides. The right side's all set to integrate, but the left side, notice, is not. If this was just 1 over y, then we could integrate it. So here you actually have to use u substitution. It's a pretty simple one. You just set u equal to 2y minus 1. And then take the derivative of that, du dy would be 2. So multiply both sides by dy. Gives you 2 dy equals du, and divide by 2. You end up with dy equals du over 2. And so then we can rewrite this as the integral of, now it's just going to be 1 over u, and then dy we can replace with du over 2. So then you can pull the 1/2 on the outside. And you can either leave it as 1 over u, or you can write u to the negative 1. Either way, remember, that's not one you can use the power rule on. Because if you had u to the negative 1, you try to use the power rule for integration, that would be u to the 0 divided by 0. You can't divide by 0. Remember, this is the formula for that, involves a logarithm. Integrate 1 over u, or u to the negative 1, gives you the natural log absolute value of u. But then we want it back into the original variable, so we can substitute back in the 2y minus 1. So we end up with 1/2 times the natural log absolute value of 2y minus 1. And then the right side, though, there's just no function inside. This doesn't require u substitution. So we can just integrate it right away. When you integrate x to the negative 3, you get x to the negative 2 over negative 2. And then plus c. And if we simplify that, we get 1 over negative 2x squared plus c. But now remember, is when we use our initial condition, in this case 2 is 0, we substitute that in for x and y. That allows us to solve for c. So when you do that, we'll have 1/2 natural log absolute value of 2 times y is 0 minus 1 equals 1 over negative 2 times x, which is 2 squared plus c. So let's just move this up here as we simplify it. So now let's see, we've got 1/2 natural log absolute value, that's just 0, so it becomes negative 1, equals 2 squared is 4 times negative 2, negative 8, so that's negative 1/8, and then plus c. And then notice what happens, this absolute value changes this negative 1 to be a positive 1, so that's 1/2 times the natural log of positive 1, so it's negative 1/8 plus c. But the natural log of 1, that's saying e to what power equals 1, because natural log is log base e, well, that would just be 0. So that's 0, that wipes out that whole side. So add the 1/8, you get c equals positive 1/8. And now we can substitute that back in right here. So our equation we have now is 1/2 times the natural log absolute value of 2y minus 1 equals 1 over negative 2x squared. And we just figured out c is positive 1/8. Now, if we want to solve, the last thing we have to do is isolate the variable that's on top of our derivative, in this case the y. You can see we want it y equals a function. So first you can multiply, get rid of this 1/2, isolate the natural log, multiply the whole equation by 2. And when you do that, remember you have natural log, but that's the same as the log base e. And then we'll have the absolute value, 2y minus 1, equals, on this side when you multiply by 2, 2 is reduced out, so you just get negative 1 over x squared, and then 2 times 1/8 is 1/4. And then to solve for the y, you'd have to switch this out of log form into exponential form to get that y outside the log. So the base is e, the exponent, and put in parentheses since there's this big exponent here, would be negative 1 over x squared plus 1/4. And that would equal what's inside the log, the absolute value of 2y minus 1. And then to deal with that absolute value, what we have to look at is sometimes an absolute value has an effect and sometimes it doesn't. So in this case, if we look back earlier in the problem, we can see the absolute value did have an effect because we had a negative number inside there, it changed to positive. So the way we represent that it had an effect there is it really the simplest mathematical way to go from a negative to a positive is it multiplies it by negative 1. So we represent that, okay, this absolute value, what it really did to this 2y minus 1 is it multiplied it by a negative 1 like that. And then to solve for y, you could distribute the negative, but I'm just going to multiply both sides of the equation by negative, so the negative would actually end up on this side. So it would be negative e to the negative 1 over x squared plus 1/4, all up in the exponent. And now, since we multiply the negative over here, now we just have 2y minus 1 over here. So then to solve for y, we would just add the 1. So then we'd have 1 minus e to the negative 1 over x squared plus 1/4 equals 2y. And the last step, just divide by 2. So our final answer for the y would be y equals 1 minus e to the negative 1 over x squared plus 1/4, all divided by 2. That would be our particular solution. All right, let's take a look at one more. On this next one, again, still trying to find the particular solution, still trying to eventually solve for y. This time our initial condition you can see is negative 2, 1, so that's the point that we know that's on the original function. Again, if we cross multiply, get rid of the fraction, just help us separate the variables, we get e to the 4y equals x plus 2, sorry, I forgot the dy, e to the 4y times dy equals x plus 2 times dx. But notice it's a little simpler in this case than the last one, because once we cross multiply, the y term is with the dy, x is with the dx, so the variable is already separated. So that allows us to integrate right away on this one. But notice again on the left side, if this was just e to the y, it would just integrate to the e to the y. But we've got this function inside there, so we have to use u substitution. So you'd set u equal to 4y, and then take the derivative, du dy equals 4. So dy would equal du over 4. And multiply by dy and divide by the 4. And that allows us to rewrite this as just e to the u. And then we can substitute in the du over 4 for the dy. Then you can pull out the constant of 1/4. And then you're left with just e to the u du. So the constant just stays on the outside. And remember, when you integrate e to the u, just like e to the x, that just stays the same as e to the u. But then we need it back in terms of the original variable, so you can substitute the 4y back in there. So we have 1/4 e to the 4y. And on the right side, that's going to be a lot simpler here. Don't need to use substitution. If this was like x plus 2 to the 5th or something, we would. But here, we can just integrate these separately since they're just added together. When you integrate x, you get x squared over 2. You find the answer of 2. That's just 2x, and then we need plus c. Then we need to know what that constant is. So again, we can use our initial condition here and substitute in for x and y. So 1/4 e to the 4 times y is 1 equals x is -2. So that'd be -2 squared over 2 plus 2 times -2 plus c. Now let's simplify this to help us solve for c. So that's just e to the 4th times 1/4, or you could write it as e to the 4th over 4. -2 squared is 4, divided by 2 is 2. 2 times -2, -4, plus c. Let's move it up here. So then we have e to the 4th over 4 equals 2 times 2 minus 4 is -2, plus c. And then just add the 2, so c would equal e to the 4th over 4 plus 2. It looks a little weird, but remember, that's just a constant, because e is approximately 2.7. The 4th power over 4 plus 2. So then we can take that c value and substitute it in right here. So let's see what we have now. We've got 1/4 e to the 4y equals x squared over 2 plus 2x, and then we just figured out c is e to the 4th over 4 plus 2. So now we want to solve it for y, but this time the y is up in the exponent. So the first thing we can do to eliminate this 1/4 to isolate the e is to multiply the whole equation by 4. So that'll wipe out the 1/4, so we'll just end up with e to the 4y equals, multiply these by 4, so that's going to become 2 goes into 4 twice, so it becomes 2x squared plus 8x, here the 4's reduced out, plus e to the 4th, and then plus 8. This time, it's kind of the reverse of what we did on the previous problem. This time the y is up in the exponent, and it's already in exponential form, so this time to get the y out of the exponent to help us solve for it, we can switch it to log form. So in log form, it would be the log, the base would be e. Remember, the log equals the exponent, so that means this whole thing would go inside the logarithm. 2x squared plus 8x plus e to the 4th plus 8 equals the exponent, which is 4y. And then you would just solve for y by dividing by 4. So that's your answer, but usually it's not going to be written that way. Usually this whole thing over 4 would be written as a constant out in front. It's just 1/4. And usually log base e, remember the short way of writing that is natural log, so they're usually written in that form as the natural log of this whole thing, 2x squared plus 8x plus e to the 4th plus 8. And that concludes the notes for AP Calculus on the topic of solving differential equations by separation of variables for exponential and logarithmic functions.